So welcome for today's lesson. So today's lesson it is interesting topic which we are having in math. Yes. So we'll start the application of differentiation. So differentiation are done and the document has already produced for differentiation. If you need that document, you can inbox me on the number 00973 178100. So you can inbox me on differentiation. We have done that without difficulty. All differentiation application, all differentiation we have done. Even the rules on differentiation we have done. Yes. So differentiation is simple and easy. Now let's dive into our today's lesson, which is application of differentiation. So application of differentiation, like the toy sheet which the toy sheet there will answer all the questions which deals with the application of differentiation part 1. So we'll try to cater all topic. So our objective on application of differentiation, so application of differentiation. So application of differentiation, the objective, you need to know what are turning point, extreme point, minimum, and maximum. So minimum and maximum, also concavity. So concavity, that deals with concavity upward or downward. I'll explain that without difficulty. That is what we consider today on application of differentiation. We'll try to explain all these concepts just giving one equation. Yes, all that concept I'll explain without difficulties. Before we start considering those, let's start with looking how we can the equation. So equation I'll just explain because those equations they are just simple. You can understand by yourself. They can tell you find the equation of the normal, find the equation of the tangent. So those they are simple and easy and straightforward. So before we start considering our today's lesson, our main focus, which is this, let us first consider the equations. How can you determine the equations of the normal and the tangent? So they can give you questions. So they will give you question like, I'll give an example, x cubed minus 2x. Then they will tell you plus 1. So that is the equation. At the point like x is equal to 1. Find the equation of the tangent or the equation of the normal. So a tangent, this is, I will say, a tangent, it's a line which touches a curve. So this is what we are calling a tangent. The line which touches the curve at a given point. If they say x is equal to what? X is equal to 1. So at here, the point there, this line is what we are calling a tangent. This line, that is what we are calling a tangent. But there is also another line which we call a normal. This is what we are calling a normal to the curve. So they will tell you, they will ask you questions. This is the normal to the curve, the tangent to the curve. Find the equation of the line. So what should you do? So the tangent, if this is the curve, if the curve they have given you what, x cubed minus 2x plus So if they have given you x cubed minus 2x plus 1, find the equation at the point of x is equal to 1. What should you do? You need to know the relationship with gradient. So gradient, if it's the tangent there, the tangent m1 is equal to what? M2. That is the tangent. Wow, if it's the normal here, normal is perpendicular to the equal, so the tangent is parallel to what? Parallel to the curve. Wow, normal there, it is perpendicular to what? To the curve. That's why the perpendicular, you learned this in grade 12, how you find the gradient, which is m1 times m2 is equal to -1. So m1 times m2, that is -1. That is the only thing which you need to know. Yes. If you know this, then you apply the concept of the equation, which is the equation of the straight line, which is y is equal to mx plus c, or you say y minus y1 is equal to m then x minus x1. So you can use these two equations. They are important. It is the same equation because just this first just require us to find what? C. But there the equation is just what? We just replace m which you have already found in the equation. And another concept which you need to know, when we differentiate dy dx is equal to what? Dy, when you differentiate dy dx, that is what you are calling what? A gradient. So when you differentiate the curve, that is what you are calling the gradient, and you apply the relationship with the m1 times m1, which is the perpendicular, which you are saying is normal. The tangent, it is the same. Yes. So let's give the same question which I gave earlier, which is x to the power 3 minus 2x plus 1. So plus 1. They ask us to find at the point where x is equal to what? X is equal to 1. They want us to find the equation of the tangent. So what should you do? So you just need to differentiate to find what? The gradient. We say dy dx of this, that is the gradient. When you differentiate this, that is the gradient. So the answer will be 3x what? To the power 3 minus what? So it will be 2 minus 2x. Here it will be what? It will be 2. We don't differentiate the constant, so it will be 3x to the power 2. Then we replace 3, we replace with this 1 squared minus 2. So what is it? 3, which is 1. So the gradient there, it is 1. So they want us the gradient of the tangent, or the equation of the tangent. The tangent is parallel. So this is the tangent. So this is the curve, which is m is equal to 1. So m to even the tangent, it will be what? 1, because the tangent, the gradient of the tangent and the normal, it is the same. So now, if we know this is 1, then you replace in the equation. Now we want to find y. How can you find y? So replace in the normal equation there. So y is equal to x. So this is the normal equation. We replace 1 to the power 3 minus 2, that 1 plus 1. So it's giving us what? Which is 1, which is 2. So 1 minus is giving -1, so it's giving us 0. So the equation there is giving us the point, which is 1 comma what? 0. Yes, that's what you need to know. 1 comma 0. That is the the uh, the the point at x. That is the point. This is important. If you find the y and x, this is important. It will be used to find in the equation, which is it will use to be find the y minus, which is y1 is equal to m. So which is m, which is x minus x1. So we know that there at 1 comma what 0, where the gradient, the first gradient give us 1. That's right. Yes. So give it, then you just replace there y minus So replace y minus what is y1, which is 0, is equal to m2, which is 1 there, which is x1, which is 1, then y is equal to what, which is x minus 1. So this is the equation of the tangent. That's all. That is the equation of the tangent. If we know the gradient, m1 is equal to m2. That is the equation of the tangent. Now let's go to normal. So to normal, we do the same. m1 times m2 is equal to negative 1. So just replace there. We just replace negative 1 there. So m2 is equal to negative 1. So if we divide by m2 there, it's giving us negative 2. Negative 1 at the same point, which is 1 comma 0. That is the same point which we use. Yes. So we know that our gradient is negative what? Negative 1. Then the point which we found is 1 comma 0. So then we will just replace y minus y1 is equal to mx minus x1. Then you just replace y minus 0 is equal to m negative 1, which is x minus x1, which is 1. So y is equal to negative x plus 1. So this is how you find the equation of the normal and also the equation of the tangent. Now let's go to our today's lesson. Yes. So our today's lesson, just as I said, the equation of the tangent and the normal, they are easy and straightforward. Our main focus was how to find the extreme values, the turning point, even the concavity, upward and downward, and how can you test if the equation increasing or decreasing. So if we have this is our equation like this. So when you look at there, what happened to y values? This point is what you are calling what? Increasing. This point is what you are calling what? Decreasing. This point is what you are calling what? Increasing. And here is what you are calling what? Turning point. Turning or stationary point, because there it is turning and here it's also turning. So these are called turning point because the curve is turning. That's why we call a turning point. So this is what you're calling what? The turning point. This is what you're calling turning. Now also, when you look at this, the turning point, they ask you what is the minimum, what is the maximum. So the maximum, it is the highest point which the curve has reached. So the highest point, this is what we're calling what? A maximum. The lowest point which the curve has reached, this is what we're calling minimum. Minimum, this is the maximum. Yes. Now sometimes they will ask you what is the extreme values. So extreme values, they are also regarding as the turning point, because they sometimes the curve will be like this. Yes, there will be this. So those are the extreme values. We will start testing them. Yes. So all this will start testing them to find the answers. Even to plot the graph, they will ask you to plot the graph like what you have sketched here. So you need to know it without difficulties. Yes. Now I have this question which will apply all these concepts which we are considering right now. So the question is this: we want to apply all the concepts, because if you find any question in the exam, you'll be able to relate any concept. If you find the maximum, find the minimum, find the coordinate of the turning point, you'll be able to answer it without difficult. Concavity, yes, is this concavity upward or downward? You'll be able to answer it. You just need to differentiate twice. Inflection point, you need to know that inflection point, You just need to know if we differentiate twice, the x values will relate to 0, that is the inflection point. Yes. So example, x to the power 3 minus 3x to the power 2 plus 5. Now the question there it is find. So first thing, or draw the curve. I would say draw the curve because this question is not specified. Draw the curve, this curve. So first we need to start to find in the turning point. We are saying that dy dx at the turning point, the gradient is 0 because the curve is not, the gradient is y2 minus y1, x2 minus x1. Now it is not increasing. We don't have, if y2 minus y1 they are the same, even x2 minus x1 they are the same. So this will mean we are saying that this, the gradient is 0. That's why when we are differentiating dy dx at the turning point should be what? 0. The gradient dy dx at the turning point should be 0. Now let's apply now. Okay. Plus 1. So x cubed minus 2x plus 1. So let's find the turning point. So dy dx should be equal to 0. So if we differentiate this, it will give us 3x to the power 2 minus 2, right? 3x squared minus 2. That is differentiate. Then we equate to 0. So because dy dx should be equal to 0 to find the turning point. So equal to 0, this will be what? So this will go this side. So this, so the equation I didn't write it properly. So it's supposed to be 3x there squared. So I want to apply all the concepts plus 5. That's the equation should be. I want to apply all the concepts, not that just answer in one type of question. So here it will be 3x squared. Then this will be what? Yeah, so this will be 3 times 2, which will be 6 what? 6x. So our differentiation will be 3x squared minus what? 6x. Then we just equal to 0. Yes. And then we'll just factorize 3x. Will be what? Here will be 3x minus what? Minus 2 is equal to 0. So the x values there, if here will be equal to 0, then this will be equal to 0. So x is equal to what? 0, and x is equal to what? X is equal to, if this will go this side, it will be negative 2. Now we have found these values. These values, they are called turning point. Yes, because that is why the equation will turn. When you differentiate, that is what we're calling the turning point. Yes, and we'll test these values using this equation to find if this will be increasing or decreasing. Yes, we'll try to test this. So let's try to test those values. How can you test those values? So x is equal to 0 and negative 2. So draw a table. So if we draw a table like this table will help us to test. Yes. So we write 0 here and 2. Then we will find those are what we have found for the turning point, 0 and 2 for x-axis. Now we want to know if the equation will be maximum or minimum at the turning point. So we'll test the number below at 0. This is going to negative infinity. So the number below 0. So I'll try to put negative 1 here. In between I'll put 1. Here I'll put 3. So I'll test if the equation will be increasing or decreasing. Yes, this will help us. So if I put negative 1 here, what will be? Let's test in our equation, which is 3 x, use, please note, use the differentiated equation. So which will be, if you put -1, here will be -1, here will be negative, so -1, which is -3, so here will be -3, here to be -3, which is will be 9. Yes, so b, so here will be, so here will be 9, which will mean it will be what? Yes, so negative, which will be here, which means when you test -1, it's giving us positive. So even the equation will be, it is also telling us something. Here it will be positive. So equation there, it has started to be positive. So we want to find the value. We can't assume that the equation will be like this, because we don't know the increasing. So increasing or decreasing, we don't know. How can we find the increasing? We find the testing values, because the turning point is 0. So below 0 here, the number is, if you know that the turning point there from x-axis here, it's 0. We don't know if from this side, then the point we don't know from this side, is it going upwards to turn upward, or is it going downward? If we say positive, so this means that it will be approaching what? Positive. It is telling us something until it reaches at the turning point A. Then we try to replace 1 to C. So if you try to replace 1 here, so if you replace 1, 3 times 3, which is 3, here 1 minus is -1. Yes. So here it's giving us negative. So -1, here 3, -3. Yes. So you are replacing 1, which is 3. This is -1. So 3 times, so it's giving us what? When you press, it's giving us negative what? 6. So which is negative here. So if we replace there, it's giving us negative. Yes. So this means that when it reaches here, it will start what? Start decreasing. It starts decreasing until it reaches another turning point, reaches 2. In between, there is 2 here. Yes. Until it reaches 2, like this. Then when it reaches 2 here, then it will do what? Because here in between 0 and 2, to find the turning, so this is the turning point 2, and this is 0 also the turning point. So just try to test the values. We test from here, this side, it is increasing, there it is decreasing. That's why it's giving negative what? -6 here. So it's decreasing. Then also we try to test what? Going what? Upward. Yes. So we try to test also here. We put a value. I said we'll just insert 3. So when we insert 3 there on the equation, 3 times 3, which is 9, here to give us 9, which is 3 minus 2. 3 minus 2, which is 1. So 9, so it's giving us 9. So 9 is positive. Have you seen the equation first? Here, so when it reaches here, it still goes what? Up. So this is what it means. It started to increase by testing the values, and then, so if they identify the maximum, so the maximum point, it is where? It is 0 here, that is the maximum. The minimum point, it is at 2, according to the testing, because the equation here to start going to the positive, then it reaches at the turning point. Then, so the equation will reach at there, at the it will start moving there. It reaches at the turning point, which is 0, and then start going to the negatives. Here it reaches at 2, then start going again to the positive, like this. So this is how the equation will be. If they tell sketch the graph, it will be like this. That will be our graph. And also they will ask you question that find concavity. They will ask you if you, so you know that increasing. So this is the graph is increasing here. This graph is decreasing here. If the graph is increasing there, the maximum point are there, the minimum point are there. You know this. Yes, you know this simple. Now, if they will ask you to find the concavity, is it concavity upward or downward? What should you do? You differentiate twice. So you differentiate twice. Our dy dx at first was what? So our dy dx at first was 3x squared minus what? 6x. Then again we differentiate again. We differentiate twice. So when you differentiate twice, this is 3x, so be 6x, that, and then minus what? 6. So we have differentiated twice there, which is dy, the 2y, and the dx squared. We have differentiated twice here. Now, if we equal this to 0, that is what we're calling the point of inflection. If they ask you find the point of inflection, you just need to differentiate twice. You equal it to 0. So here when you equal to 0, what will be our x? This side x will give, this will be positive. Then x we divide by 6, we divide by 6, so it will be 1. That will be our x. And so this is how you find the point of inflation. Find the point of inflation. You just need to equate the second derivative twice. Yes, that is the point of inflation. Now, how can you determine the concavity upward or downward? So use also the testing values. So we know we just use this 1. So here we just write 1 here. You know 1. We test if above 1 it's, I'll say you 2, below 1 it is 0. So we'll test here in this equation to see if it's going up or is it going down. So when you test there in the dy dx, the first equation there differentiated, which is 6x minus 6. When differentiate there, we replace by these two testing values, 0 minus 6. So it's giving us what? Negative 6. So here it's giving you negative 6. So what does it tells you? So it tells you that here when it gives you negative, so we develop that if two differentiate, if we differentiate twice, it is less than 0. That's what we are calling concavity downward. So concavity downward. So here that's what we are calling concavity downward. But if we differentiate twice, then we find the greater than 0. That's what we are calling concavity upward. So concavity upward. That's what we are calling concavity upward. So try also to test this bad, which is 2. So here we found negative. So it means that from 0 going to 1, that is what we're calling concavity. Concavity what? Concavity downward. If 2, there we try to test 2 in the equation. Where this is the equation, we try to put 2 here. So 6, which is 12. 12 minus 6, which is 6. That's what we are calling positive here. So this side, this is concavity upward. Yes. When you look at that equation, so the point of inflection is 0. So point of inflection was 1, and concavity upward and downward, we have answered it. So this is what you should know about concavity, extreme values, the turning point. Yes. So if you have any question, you can inbox me on the number 0973 178100. Yes. So this is what you need to know. So it's simple and easy.